pre-calc students, the last thing we're going to look at are applications of right triangle trig. There's two terms you got to know. The first is the angle of elevation. It's kind of exactly like it says. What it is the acute angle formed by the horizontal line in the line of sight. So let's say, example, you're standing here and you're looking up at a kitten who's stuck in a tree. So here's the tree. Here's the poor little kitten. That's its tiny tail. The angle of elevation would be, if you were to take a line, draw a line, a horizontal line, straight across, your angle of elevation would be this angle theta that it takes for you to tilt your head up to look at the cat. Similarly, the angle of depression is likewise defined, but the line of sight is, so it's exactly the same as the angle of elevation. The only difference is, instead of looking up, you're rotating down. This is an example from your book. I thought it was particularly hilarious, maybe because the guy just got laser in eyesight. But it's taking this horizontal line, and he's rotating down to the line of sight, what they're actually looking at. That's your angle of depression. You can use these to find some basic problems. For example, you're trying to estimate the height of a sculpture. So here's you. Here's your sculpture. I don't know. It's a sculpture of a kitten in a tree. A very original sculpture, right? You're trying to elevate what that is. You're standing 5 feet away. And what it's saying is, you can see the top of the sculpture with an angle of elevation of 79 degrees. Now, this is very poorly drawn, but this angle that you would have to elevate your head, you tilt your head to, is 79 degrees. Now, we know this horizontal distance is also going to be 5, so I'm just going to kind of transfer it up. And it's asking, how tall is this sculpture? This is kind of a poorly worded question, because how tall the sculpture is kind of depending on your height. So I'm the one answering the question, so I'm going to say I'm 6 feet tall, this person's 6 feet tall. So, but what we need to find, if we call this thing h, that's going to be the height of from where I'm looking straight up to the top of that cat. So when we look at this, we can assume that this is a right triangle. We assume the sculpture is not slanting too much. And what we're going to take a look is what side relation exists between this 5, the h, and 79 degrees. That's going to be tangent. The tangent of 79 degrees will equal the opposite height over 5. In other words, the height will equal 5 times the tangent of 79 degrees. We can type that into our calculator in order to help us figure it out. Here, my calculator's in a mode of degrees, so I don't get anything goofy. And I'm going to hit 5 times the tangent of 79 degrees. When I enter that, is 25.7 feet, but that's in addition to my 6 feet tall. So the total height would be 25.7 feet plus 6 feet, which equal a 31.7 foot sculpture of a cat in a tree. A little more complex is kind of taking these to multiple steps. So for example, from his hotel room in the 6th floor window, Singh notices that some window washers above him across the street. So here's the window washers. Here's our boy. It says, curious to his height, he quickly estimates the building around 50 feet apart. So we know that's 50. And the angle of elevation of the workers is about 80 degrees, as indicated. The angle of depression is about 50 degrees. We're asking two questions. One, how high above the ground is the window in Singh's room? So if this is 50, it's asking for this height 1. Again, what relates the 50, which is the adjacent, the h1, which is opposite? The tangent of 50 degrees will equal opposite h1 over 50. Multiply 50 times the tangent of 50 will equal h1. Plug that into our calculator, 50 tan 50, hit enter, we come up with 59.6 feet. So the first height is 59.6 feet. For our sake, that's close enough. We'll just go ahead and call that 60 feet. So, height 1, 60 feet. Now the second question is saying how high above the ground. Well, we don't really know how high above the ground based on current information, but if we get this second height, we'll know the total height above. So again, what relates h2 opposite 50 is going to be tangent. So the h2 will be the tangent of 80 degrees equals the opposite h2 over the adjacent 50. So 50 times the tangent of 80 will equal h2. H2 will equal 50 tangent 80, enter, 283 feet. We'll round that off to 284. 284 feet. So their total height up would be 284 feet plus 60 feet, which gives us a grand total of 300 and what is that? 44 feet.